Hi! Welcome! In this video, we are going to learn about the operators in C. First, we need to answer the question, what is an operator? An operator is a symbol that operates on a certain data type. The data items that operators act upon are called operands. Take this as an example. The variables a and b are the operands and the plus symbol is the operator. Some operators require two operands, some operators act upon only one operand. In C, operators can be classified into various categories based on their utility and action. Several operators are arithmetic, increment or decrement, relational, logical, bitwise, assignment, Sizeof, conditional, and comma. The arithmetic operators performs math operations. The arithmetic operators can operate on character, integer, float, or double data type. This type of operator is used to compare arithmetic, logical, and character expressions. Here are the list of the arithmetic operators and their use. First, we have the plus operator which adds two operands. Example, variable equals a plus b. Next, the minus operator that subtracts the second operand from the first. Example, variable equals a minus b. Then we have the times operator that multiplies both operands. Example, variable equals a times b. And lastly, the division operator that divides the numerator by the denominator. Example, variable equals a divided by b. Increment or decrement operator changes the value of an operand, whether it's a constant or a variable, by 1. This type of operator acts upon a single operand and produce a new value. It is also called as unary operator. Here is the list of increment and decrement operator and its use. First, we have the increment plus used as a prefix. This increases the value by 1 then returns the value. When increment plus operator used as a suffix, the original value is returned first then increases the value by 1. Next, we have the decrement minus used as a prefix. This decreases the value by 1 then returns the value. When decrement minus operator used as a suffix, the original value is returned first then decreases the value by 1. The decrement operator works in a similar way to the increment operator, except that the decrement operator decreases the value by 1. Relational operators are used to compare arithmetic, logical, and character expressions. This operator compares their left-hand side expression with their right-hand side expression. It is used to compare value of two expressions depending on their relation. If the expression is false, it evaluates to 0. If the expression is true, it evaluates to 1. The expression 1 will be compared with expression 2, and depending on the relation, the result will be either true or false. Here is the list of relational operators. First, the equal to checks if the values of two operands are equal or not. If yes, then the condition becomes true. Example, A is equal to B. Next, the not equal to checks if the values of two operands are equal or not. If the values are not equal, then the condition becomes true. Example, A is not equal to B. Then, the less greater than relational operator checks if the value of left operand is greater than the value of right operand. If yes, then the condition becomes true. Example, A is greater than B. We also have the less than relational operator, checks if the value of left operand is less than the value of right operand. If yes, then the condition becomes true. Example, A is less than the value of B. Next, the greater than or equal to checks if the value of left operand is greater than or equal to the value of right operand. If yes, then the condition becomes true. Example, A is greater than or equal to the value of B. Lastly, the less than or equal to checks if the value of left operand is less than or equal to the value of right operand. If yes, then the condition becomes true. Example, A is less than or equal to the value of B. Let's check if the conditions are true with the following examples. Logical operator is used with one or more operand and return either value 0 for false or 1 for true. The operand may be constant, variables, or expressions. A logical operator is used to evaluate logical and relational expressions. And the expression that combines two or more expressions is termed as logical expression. C has three logical operators. Represented by two ampersand, this is called logical AND operator. If both the operands are non-zero, then the condition becomes true. Next, represented by the two vertical bars, called logical OR operator. If any of the two operands is non-zero, then the condition becomes true. Lastly, represented by an exclamation point, called logical NOT operator. It is used to reverse the logical state of its operand. If a condition is true, then logical NOT operator will make it false. Logical AND. The result of a logical AND operation will be true, only if both operands are true. Expression 1 on the left-hand side will be compared with the right-hand side expression. The results of logical AND operators are: if both expressions are true, then the result will be true. If either of the two expressions is false, then the result will always be false.
And if both expressions are false, then the result will always be false.
Let's check if the end results will be true. Given the values of each variable, A is 10, B is 20, C and D is 0. For logical OR operator, again, this will compare both expressions.
The result of a logical OR operation will be true if either of operands is true.
In logical OR, this table shows that if either of the expression is true, the result will be true. But if both expression is false, of course, the end result will be false. Let's check if the end results will be true. Given the values of each variable, A is 10, B is 20, C and D is 0. Lastly, in logical NOT, the NOT operator reverses or flips the result from being true to false or vice versa. In this table, adding the exclamation point to represent the NOT operator flips or reverses the result. Let's check if the end results will be true. Given the values of each variable, A is 10, B is 20, C and D is 0. Bitwise operator permit programmer to access and manipulate of data at bit level. Bitwise operators are operators that operate on integers and unsigned integers at the binary level. Let's have a review on how to convert decimal number to binary number.
So how can we convert 75 into a binary number? It helps to be familiar with the powers of 2. 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the sixth power is 64, 2 to the seventh power is 128. Now we don't need to go further because 128 exceeds 75. So the highest number, that is the highest base 2 number that is less than 75 is 64. So we're going to start with 64. Now in this video, I'm going to show you 2 ways to convert a decimal number into a binary number. The first half of the video will focus on the subtraction method, and the second half will focus on successive division. So I'm going to show you both ways, and then you can pick and choose which method you prefer. Now once you have your first number, which is 64 in this case, subtract. Let's subtract 75 by 64, and so that will give us 11. Now the highest number that's under 11 is 8. 16 exceeds 11, so we can't use that. So let's put an 8 here. And then let's subtract 11 by 8. 11 minus 8 is 3. And so the next highest number just under 3 is 2. And so let's put a 2 here. And then 3 minus 2 is 1. And so the next highest number is a 1. And we could stop here. Because if you add these numbers, 64 plus 8, that's 72. 72 plus 2 is 74. 74 plus 1 is 75. These 4 numbers add up to 75. Now once you have that, you can begin to write the numbers in binary. So because we have a 64, we're going to put a 1. We don't have a 32, so let's write a 0. We don't have a 16. We do have an 8, so let's put a 1. We do not have a 4, so let's put a 0. But we do have a 2 and a 1. So 75 is equal to 1001011. And so that's one simple way in which you can convert a decimal number into a binary number. Now here's another example. Let's say if we have the number 142. Let's convert that into a binary number. So let's write the list of numbers that we're going to work with. 128, 64, 32, 16, 8, 4, 2, and 1. So the highest number under 142, the highest base 2 number, is 128. So let's start with that. And then if we subtract 142 by 128, that's going to give us 14. And so the next highest number just under 14 is 8. And so 14 minus 8 will give us 6. But let's put the 8 here. Now the next highest number that's under 6 is 4. So if we subtract 6 by 4, that will give us 2. So let's put the 4 here. And then 2 minus 2 will give us 0. So we could stop at the 2. And so you could check it. If you type in 128 plus 8 plus 4 plus 2, that will give you 142. So make sure that these numbers add up to this number. So you want to find all the base 2 numbers that add up to this number. Once you do that, then you can convert it into a binary number. So this is going to be 1. We don't have a 64, nor do we have a 32 or a 16. We do have an 8, a 4, and a 2, and we don't have a 1. So 142 is basically 1, 0, 0, 0, 1, 1, 1, 0. And so that's how you can convert a decimal number into a binary number.
During computation, mathematical operations like addition, subtraction, multiplication, division, etc. are converted to perform bit-level operations. Various bitwise operators as follows. Represented by a single ampersand, bitwise and operator copies a bit to the result if it exists in both operands. Represented by a single vertical bar, bitwise or operator copies a bit if it exists in either operand. Represented by a caret, bitwise XOR operator copies the bit if it is set in one operand but not both. Represented by a tilde, bitwise one's complement operator is unary and has the effect of flipping bits. Represented by two less than symbols, bitwise left shift operator. The left operand's value is moved left by the number of bits specified by the right operand. Represented by two greater than symbols, bitwise right shift operator. The left operand's value is moved right by the number of bits specified by the right operand. Using the values on the video about converting decimal numbers to binary numbers as an example for coding. Assignment operator is used to assign a value to a variable. The most commonly used assignment operator is equal sign. Operand on the left. The general format for assignment operator is identifier equals expression, where identifier represent a variable and expression represents a constant, a variable, or a complex expression. If the two operands in an assignment expression are of different data types, then the value of the expression on the right will automatically be converted to the type of the identifier on the left. Here's the list of assignment operators in C. The equal sign, simple assignment operator, assigns values from right side operands to left side operand. The plus equals adds the right operand to the left operand and assign the result to the left operand. The minus equals subtracts the right operand from the left operand and assigns the result to the left operand. The times equals multiplies the right operand with the left operand and assigns the result to the left operand. The slash equals divides the left operand with the right operand and assigns the result to the left operand. The modulus equals it takes modulus using two operands and assigns the result to the left operand. The two less than sign followed by an equal sign, left shift and assignment operator. The two greater than sign followed by an equal sign, right shift and assignment operator. The ampersand equals is bitwise and assignment operator. The caret equals is bitwise exclusive or an assignment operator. And lastly, the vertical bar equals bitwise inclusive or an assignment operator. The sizeof operator is a unary operator that returns the size of data, constants, variables, array, structure, etc. This operator allows to determine the number of bytes allocated to various data items. Sizeof is a keyword in C. This returns the size of a variable. Example, size of a where a is integer will return 4. Conditional operators, sometimes called as ternary operator. Since it requires 3 expressions as operand and it is represented as question mark, comma, and colon. Generally it is used to make portable program. It determines the length of entities, arrays and structures when their size are not known to the programmer. It is also used to allocate size of memory dynamically during execution of the program. The ternary operator acts like if-else construction. The syntax, expression 1, question mark, expression 2, colon, expression 3. Expression 1 is evaluated first. If expression 1 is true, then expression 2 is evaluated, otherwise expression 3 will be evaluated. A question mark followed by a colon is a conditional expression. If condition is true, then value of x, otherwise value of y. Lastly, the comma operator allows different expressions to appear in a situation where only one expression would be used. All expressions are separated by comma and are evaluated from left to right. That's it. Hopefully, you have understood the operators in C. If you have any question, you may contact me through my social media accounts. Thank you. See you on the next video. Goodbye.